Welcome to ni class 12 unit 13 here simlingo a topic here organic compounds containing nitrogen here. Objectives I simlingo here nomenclature of amines, nitro-compounds, cyanides and isocyanides. Methods of preparation prepared on chemical to physical properties. Then identification of primary, secondary and tertiary amines. Ambident nucleophiles is a nucleophile which is an electron-rich species, has a pair of electrons on each side of the two or more atoms is known as ambident nucleophile. Ambident nucleophile is a nucleophile. It's a nucleus file is a loving nucleus loving. So nucleophile is a negative charge anyway. Ambident is a both sides are its own ambident. See number C and here structure must appear and there C in a minus charge and in her lone pair of electrons and here second resonating structure C in a lone pair of electrons and here and in a minus name and it also a minus charge need to him an ambident nucleophile. See second one NO2 minus pen here oxygen nitrogen has lone pair of electrons. Second structure here minus O pen is shift more like this, like a shift. So first structure minus pen here left side of oxygen benzene. Second structure here minus pen right side of oxygen. So this type of structure here or this type of nucleophiles here ambident nucleophiles. Cyanides, cyanides. Structure CN here common system naming the alkyl or aryl cyanide. IUPAC system alkane nitrile. Masala and CH3 C triple bond N. So alkyl or aryl cyanides, alkyl CH3 here methyl so methyl cyanide or acetonitrile. It's IUPAC name here the alkane plus nitrile, so ethane. Two carbon atom add ethane plus nitrile, ethane nitrile. So same thing and one here CH3 CH2 C triple bond N. CH3 CH2 here ethyl. So we have ethyl cyanide, IUPAC name propane nitrile. Third one 1 2 3 4 carbon atom. So propyl cyanide or butyronitride, IUPAC name here butane nitrile. So preparation of cyanide number 1 from acid amide. Pure nitriles can be obtained by dehydrating acid amide with P2O5 or thionyl chloride. So amide RCONH2 here P2O5 or thionyl chloride SOCl2 to occur reaction dehydrating acids. Dehydrating is removal of water molecule. So water molecule H2O NH2 H2. So this water molecule gets removed. So you get R C triple bond and nitrile molecule. Number 2 from alkyl halides. Nitriles can be obtained by refluxing an alcoholic solution of an alkyl halide with potassium cyanide or sodium cyanide. So sodium cyanide when alkyl halide to occur reaction you get alkyl nitride. Number 3 from diazonium salts. Aryl nitrides can be conveniently prepared by treating arene diazonium salts with a mixture of copper 1 cyanide and potassium cyanide. So diazonium salt here potassium cyanide with copper sulfate okay mix you get aryl cyanide. or aryl nitrile. Number 4, Grignard's reagent upon an alkyl cyanide can be prepared by the action of Grignard's reagent on cyanogen chloride. So Grignard reagent is there in RMgX mom. Suppose R here the CH3 you have CH3 MgBr. So it reacts with ClCN cyanogen chloride. Under dry ether you get methyl cyanide. Physical properties of nitriles and isonitriles. Nitriles have pleasant smell, whereas isonitriles have disagreeable smell. Nitriles they hele gimnam toymo, himala isonitriles they hele gimnam siya. And isonitriles to nitriles are highly polar. Highly polar is a charge separation of charge and exhibit high boiling points. Boiling point why? Because of strong intermolecular hydrogen bond between the molecules. Number 3, they are generally colorless. Number 4, lower members of nitriles are soluble due to intermolecular hydrogen bonding. Isonitriles, however, are insoluble in water. Nitriles they here hydrogen water are soluble in isonitriles they here they are soluble in. Chemical properties of nitriles and isonitriles. Hydrolysis. Nitriles or alkyl cyanides are hydrolyzed to acids by mineral acids or alkalis, where amides are formed as an intermediate. So nitriles say hydrolyze hydrolyze means addition of water. So hydrolyze you get carboxylic. Carboxylic form minor. This one form minor. Reaction intermediate hele amide CH3 CONH2 reaction intermediate form. Reduction. Nitriles on reduction with sodium or alcohol or lithium aluminum hydride or nickel hydrogen to yield primary amines. Reduction. It is a removal of oxygen or addition of hydrogen bomb. So cyanide reduction reaction undergoes in presence of catalyst. You get amine, primary amine bomb, RC. Isonitriles they reduce you get secondary amines. So that is the difference. Uses of cyanides. Nitriles or alkyl cyanides are useful intermediates in organic synthesis. Nitrile or alkyl cyanide in organic synthesis are intermediate. Formation of nitrile from an alkyl halide is used to increase carbon atom in the molecule. Alkyl reaction alkyl nitride or nitrile formation alkyl halide carbon atom chain increase reaction pen nitrile pen Number 2, ethane nitrile solvent to perfume ball na Number 3, acetonitrile solvent and acyl nitrile textile rubber industry.
Nitro-compounds. Compounds containing nitro group are known as nitro-compounds. The nitrogen atom is directly linked to a carbon atom of an alkyl or aryl group. So compound in a nitro group, NO2 group nitro-compound. So in alkane, alkyl derivative R CH2 NO2 R2C R3 NO2 R2 R3 R4 NO2 alkyl group attachments in benzene ring. This is benzene ring attached to nitrobenzene. So two groups are here 1 2 3. So at one position to 3 position in nitro group or more. So we have 1, 3 dinitrobenzene. Third one, ethyl group, nitro group in functional group tama. So this becomes substituent. So CH3, CH2 ahile ethyl gitima. We have 2 ethyl nitrobenzene. Nomenclature of compounds. Nitroalkanes are named by prefixing nitro to the name of the parent hydrocarbon. Nitro-compounds stay here, nitropentane masenzin, also hydrocarbon chain pin, and next nitro kitang CH3 NO2 here, NO2 gigal masamo, nitro CH3 here, hydrocarbon parent chain here methane mo. Then C2H5 NO2 nitro methane, C3H5 NO2 nitro propane, C6H5 NO2 nitro benzene. Preparation of nitro compounds from alkyl halides. Nitroalkanes are prepared by treating an alkyl halide with aqueous ethanolic solution of silver nitrate. Nitroalkanes dehile alkyl halide apatina ethanolic solution of silver nitrate to mix home ina nitroalkanes tekimo. Then by nitration. By nitration, nitroalkanes are prepared in large scale by the reaction of alkanes with nitric acid in the vapor phase at about 6 to 3 Kelvin. Alkanes with more than 2 carbon atoms form a mixture of nitroalkanes. So nitroalkanes stay here, large scale mass production pen alkane te to nitric acid take a reaction you get more than 2 carbon atoms or a mixture of nitroalkanes. Yeah, masanaina you have 1, 2, 3 nitropropane primary carbon, 2 nitropropane, then nitroethane and nitromethane to form. Physical properties of nitrocompounds. Nitrocompounds say hele colorless, wrongly lomo, they're pleasant smelling liquid. Then nitrocompounds say hele to soluble lomo, but readily soluble in organic solvents. Organic solvents are easily soluble. Number 3, they are polar compounds and can be distilled at atmospheric pressure. Number 4, boiling points with increasing molecular weight, the solubility decreases. Molecular weight atom a chain atom solubility pain decrease. Nitrobenzene pale yellow liquid yellow liquid cut a smell bitter almond smell okay banga. Aromatic nitro compounds to soluble low but soluble in organic solvents. Chemical properties of nitro compounds. Number 1, reduction to nitroalkanes. Nitroalkanes under reduction give different products. Number 1, acidic medium nitroalkane are reduced using metal. In acidic condition, you get primary amine. Catalytic reduction nitroalkane to hydrogen using nickel as catalyst. Primary alkane. Then number 3, neutral medium, reducing medium RNO2 pain. Reduce R NHOH. OH pain. Hydroxylamine. Uses of nitro compounds. They find use in the manufacture of hydroxylamine. Then again, number 2, nitro compounds dyes, explosive or detergents. They are starting material. Here, number 3, nitroalkanes plastic industry. Number 4, nitromethane liquid proper. Nitromethane liquid propellant nitrocellulose gels in nitroglycerin are used as solid propellant. Number 5, chloropicrin is used as an insecticide. Chloropicrin, picric acid 136 trinitrobenzene here. So chlorine ki substitute changina picric acid chloropicrin kitsimo. So chloropicrin hile insecticide kizang. So nitrobenzene nitrobenzene hile laboratory ki prepare dalina benzene to nitric acid ki mix changina nitrobenzene ki momo. So a ball down here gets me. So nitric acid HNO3 plus H2SO4 happen first step 1 get NO2 plus more. So NO2 plus when electrophile here. So this benzene ring attached an electrophile. So final product nitrobenzene chemo. Physical properties of nitrobenzene. Nitrobenzene ahi lipid yellow liquid here. Salt pe ki ko changina color penong chik deu. Nitrobenzene hele 483 Kelvin boiler specific gravity hele 1.087 here. Gimnama hele aniline to gibanga bitter almond dande mo gim. Number 4 nitrobenzene hele soluble hekia himale benzene toluene alcohol and ether soluble vector here. Chemical properties of nitrobenzene. Electrophilic substitution. Nitro group is a deactivating group, so further substitution takes place in meta position. So nitro group is a deactivating group. A benzene structure a benzene ring pen electron lahya mo deactivate here deactivate manina substitution pen NO2 chawa amthai mo meta position chawa amthai. So nitrobenzene nitration is NaHNO3 under acidic H2SO4 condition. So NO2 pen hele meta ortho meta mo meta para. So meta position na NO2 khat ki add mo hele 1,3 dinitrobenzene. Sulfonation na hele same thing the sulfonic acid ki add. So meta nitrobenzene sulfonic acid. Chlorination na hele danati mapagina meta position of chlorine atom khat ki add mo. So we have 1, 2, 3 meta chloro nitrobenzene. Reduction of nitro-compounds. Nitro-compounds undergo reduction to give different products with different reducing agents. So nitro-compounds hele acidic condition under FeHCl or SnHCl NO2 pen hele NH2 aki reduce mo. Under basic conditions 3 types of in basic conditions nitro compounds reacts with zinc dust or sodium hydroxide and methanol to give azobenzene. Your reaction pen aki zinc dust to sodium hydroxide so hydrazobenzene kimomo. Number 3 Na2ASO3 in presence of sodium hydroxide azoxybenzene kimo. Third type neutral medium zinc to ammonium chloride. You get phenyl hydroxyl amine. Number 4 now electrolytic reduction of weakly acidic medium aniline kimwa happen no. In strongly acidic medium hydroxyl amine kimwa rearrangement hom changina you get para amino phenol. Uses of nitrobenzene. Nitrobenzene hele Nitrobenzene hele fluor polishes take ibona dena kizanga. Number 2, as a cheap perfume in soap and shoe polishes. Perfume danina sabon kong and the shoe polish kong ina nitrobenzene kizanga. Oxidizing agent in organic synthesis and kizanga. Number 4, aniline to dye ke bolna dinga nitrobenzene hele kizata pina he. Amines. Classification of amines. Amines are classified as primary, secondary, and tertiary depending on the number of hydrogen atoms replaced by alkyne or aryl groups. So, amine NH3 ahile ammonia mo. The NH3 hydrogen thum omna laka if one hydrogen is replaced by R group. Hydrogen pentum oma. So any hydrogen group is replaced by R. Here R mo. Hingzangina amine kasi. So two hydrogens are replaced by R group. 1, 2. We get secondary amine. 3 hydrogens in a 3 hydrogens pen 3 R group in a replaced in a tertiary amines kasi. Structure of amines. Nitrogen orbitals in amines are sp3 hybridized and the geometry of amines is pyramidal. The 3 sp3 hybridized orbitals of nitrogen overlaps with orbitals of hydrogen or carbon. The fourth orbital contains an unshared pair of electrons. The angle between the C and A, where A is C or H, is less than 109.5 degree, while in case of trimethylamine it is 108 degree. Nitrogen structure helium. sp3 nitrogen and sp3 hybridization ania a geometry ahile pyramidal ma. So 3 sp3 hybridized orbital pair hydrogen ahilone alkyl group to agi overlap then the fourth orbital hile unshared pair of electrons pen lone pair of electrons mo. So angle hile n H angle pen carbon CH4 methane sangina neo ka anyam zoa in 109.5 degrees sangina anyam zoa to trimethyl amine is CH3 holding 3 and angle hile 108 degree. Nomenclature of amines. Common name mahile alkyl amine akitia IUPAC name mahile alkane plus amine. So number 1 CH3 CH2 and H2 common name alkyl amine mo. So CH3 CH2 happen mahile ethyl plus amine ethyl amine kiti. IUPAC name alkane plus amine alkane 2 carbon atom add ethane amine. Sorry. Second one CH3 CH2 CH2 and H2 the N propylamine IUPAC name है propane 1 amine. Third one isopropylamine propane 2 amine. Now CH3 holding 3 N है triethyl amine or NN dimethyl methane amine. Preparation of amines. Amines te hile nitro-compounds te reduce yangina amines kibomo using finely divided nickel or palladium or platinum and also by reduction of metals in acidic medium. Nitroalkanes can also be prepared. Nitroalkanes can also be similarly reduced to corresponding alkane amine. Number 2, reduction of nitriles. Nitriles stay here reduced enough using lithium aluminum hydride or as a catalyst hydrogenation reaction primary amine. So this reaction is used for ascent of amine series, that is preparation of amine containing one carbon atom more than the starting amine. So here pen again na hele amine series to a series se RCH2 C carbon atom pen ki increase udane the reduction of nitriles ki sangzel mo. Number 3, reduction of amines. Amides, reduction of amides, AMIDES, amides. So amides they are reduced young enough, you get amines. The Hoffmann-bromamide degradation reaction hi pena ile I'm poimo mamamu amine reaction adinga poimo khata hiya amines can be prepared by treating amide with bromine in an aqueous ethanolic solution of sodium hydroxide. So amide CH3CO and H2 pen amide acetamide plus Br2 plus sodium hydroxide a solution. Penalty of function you get methanamine plus sodium bromide plus Na2CO3 plus 2H2O. So similarly, propanamide pen bromine water using sodium hydroxide. So here you get ethanamine. Gabriel phthalimide synthesis. Gabriel synthesis is used for the preparation of primary amines. Phthalimide on treatment with ethanolic potassium hydroxide forms potassium salt of phthalimide, which on heating made alkyl halide followed by alkaline hydrolysis produces the corresponding primary amine. So aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution with the anion formed by phthalimide. The phthalimide ahile alkyl amine de primary amines de tangpe na kibola aromatic amines de kibol thailo Gabriel phthalimide synthesis. So aromatic compounds in a nucleophilic substitution Taylor reaction undergo Taylor. Physical properties of amines. Lower aliphatic amines are gases with fishy odor. Primary amines with 3 or more carbon atoms are liquid. Aliphatic amines they carbon yamla mate hele namse homo. Primary amines they are tangpina a property will have liquid physical appearance mo aniline and other aryl amines ahile amount wrong nailo mo color nailo. So primary and secondary aliphatic amines they ahile amount intermolecular hydrogen bonding with other nitrogen atom of another molecule can undergo intermolecular hydrogen bonding with other molecules. Chemical properties. Number 1, basic nature of amines. Amines being basic in nature react with acids to form salt. Amines they hele halogen acids to akigong form changuna salt kimoma. Acylation. Aliphatic and aromatic primary and secondary amines react with acid chlorides and hydrides and esters by nucleophilic substitution reaction. This reaction is known as acylation. The products obtained by acylation reaction are known as amines. The reaction is carried out in presence of a stronger base than amine. The acid chloride this acid chloride to amine then you get amide compounds. Number 3, carbolamine reaction. Aliphatic and aromatic primary amines on heating chloroform and ethanolic potassium hydroxide form isocyanides or carbolamines, which are foul-smelling substances. This reaction is known as carbolamide reaction or isocyanide test and is used as a test for primary amines. Carbolamine reaction ahile primary amines de a conformation na dinga A given compound is whether primary or secondary or tertiary. When primary take azonadina carbolamine reaction kitase mo aliphatic aromatic primary means ke hele chloroform to potassium hydroxide to heat changina you get isocyanide NC. CN na hitangina cyanide mo NC hitangina isocyanide. Okay, reaction with nitrous acid. Three classes of amines react differently with nitric acid. Primary amines with nitrous acid to form aliphatic diazonium salts which being unstable liberate into gas. So here primary amines they here. Okay, primary amines there nitrous acid HNO2 under sodium nitrate and NO2 plus HCl. You get diazonium salt. So this diazonium salt is the important compound dang synthesized here. So diazonium salt pen later hydrolyze you get alcohol plus N2 gas plus an acid. Number 4 reaction with arylsulphonyl chloride. So benzene sulfonyl chloride, which is also known as Hinsberg reagent, reacts with primary and secondary amines to form sulfonamides. So the hydrogen attached to nitrogen in sulfonamide is strongly acidic due to presence of strong electron withdrawing sulfonyl group. Hence, it is soluble in alkali. So, benzene sulfonyl chloride when amines, primary or secondary amines that react, you get compound called N-ethyl benzene sulfonamide. Have compound hele alkali soluble this hydrogen attached to nitrogen is very acidic. Why? Because SO2 SO2 more when electron withdrawing electron withdraw here because of strong electron withdrawing properties of this group, this hydrogen becomes very acidic. Aniline, yan something aniline ay the benzene structure plus NH2 hitsang na aniline. NO2 hitsang ina dinapin nitrobenzene kasi mo. So physical properties of aniline, it is a colorless oily liquid with characteristic fishy odor. Aniline ahile arong nilaw oily liquid ahiya agim ahile namsiya hiya nga gimto gibang mo. Anili na hile hui lag ahile avakla ka. Aki ko isang ina brownish color. Kung kiswag mo. Anili na hile to be a slightly soluble hiya himali organic solvent na hoy diwa soluble. Chemical properties of aniline. Basic nature. Due to presence of an electron pair on the nitrogen atom, aniline accepts a proton and thus behaves as a gas. So nitrogen pair, it has lone pair. This one lone pair, another lone pair. So this lone pair donates a pair of electron, comes here, and this one shifts. After shift you get CH minus. No. So this minus again undergoes resonance and comes here down. So you get CH minus. The minus when we like by in the ring it undergoes resonance, we get CH minus. So allows the CH minus donates an electron here, and this double bond shift to here. So you get same compound. So structure 1, 1, 2, 3, 4, 5. So structure 1 to 5 pentibang more. And aniline nitrogen atom in aniline na minus a lone pair of electrons and it behaves as a it accepts a proton and thus behaves as a base. Aniline is, however, less basic than ammonia and aliphatic amines. It is resonance hybrid of the following above structures. Since the electron pair on nitrogen atom is also displaced towards the ring, it is less available for coordinating with the proton. Moreover, a positive charge on the nitrogen atom structures 1, 2, 4 and 5 will repel a proton and thus makes an aniline weaker base. Thus, a weak basic nature of aniline is due to resonance and small positive charge on the nitrogen atom. Then again, so aniline pain, why banga bangya base, strong base because it donates this electron. Okay. But donate electron pin donates you get double bond here. Okay, because this double bond is next to the benzene ring adjacent it undergoes resonance. So resonance undergoes it becomes very stable. No, a stable electron pin donate no more. But aniline pin weak base on swap more. Electrophilic substitution of aniline, bromination. Aniline reacts with bromine water at room temperature to give a white precipitate of 2,4,6 tribromoaniline. Aniline ahile bromine water to reacts in 2,4,6 tribromoaniline chemonitrate. Aniline pain nitrate pain direct first acylation take place. This one. Acylation equivalency. So acylation is acetanilide. But more. Then nitrate pen ki add. HNO3 more nitration pen ki add. Nitration ki add sangina you get ortho nitro aniline or para nitro aniline more. Two product multi. Number 3, sulfonation. Aniline pain, sulfuric acid of the heat you get para substituted sulfonilic acid. Sorry, NH2 pain para substituted. 4 amine, benzene, sulfonilic acid. Basic characters of amines. Aliphatic amines here. Lone pair of electrons on nitrogen aroma, thus with a strong tendency to the lone pair of electrons, making the amine behave as bases. So lone pair of electrons and manuna nitrogen 10 a lone pair of electrons when nitrogen behave as base is same. Aliphatic amines is stronger bases than ammonia due to the reason that alkyl groups are electron donating. As a result, the electron density on nitrogen atom increases. Hence, they donate the lone pair of electrons easily compared to ammonia with only hydrogen atoms. So, ammonia hele NH3 mo N 1, 2, 3. Hydrogen atoms here. Primary amine this one hydrogen is replaced by R group. So secondary 2 R group. Tertiary 3 R group. No. So then again because of this R group is alkyl groups here. Alkyl groups electron donating. No. So this electron donating. The R group electron donating. No. This electron donating. So R group electron donating they donate electrons towards nitrogen. So this nitrogen pin electron rich electron rich it can this is electron rich. So it can donate more electrons, so it becomes more basic. Okay. Aromatics are they are weaker bases than ammonia and aliphatic amines. The weaker basic nature of aniline may be due to delocalization of the lone pair of electrons over the benzene ring and thus is less easily available for protonation. Therefore, aromatic amines are weaker bases than ammonia. So aniline na hile NH2 lone pair of electrons on mamo. So this lone pair of electrons danadana free amlowinsin ring on manina conjugated pi electrons on manina. This ammonia or NH2 lone pair pain kidonate nitrogen and donate engine you get double bond here double bond on more because nitrogen loses an electron it loses one electron 1 plus you get more. So this molecule or this C carbon bond it gains one electron or minus no then I give shoot. So in aniline, yeah, a lone pair pen, a ringer resonance omtines, so this nitrogen becomes plus plus. So nitrogen when positive charge on hizakina electron rich on inolomo, electron rich inolomo manina, it becomes weaker base. Effects of substitution and basicity of aromatic amines. Electron donating group EDG electron donating group like methyl OCH3 NH2 changina a basicity pen aki increase himale electron withdrawing groups like NO2 CN X changina a basicity pen ki decrease mo bangda why is it electron donating group ina it stabilizes the conjugate acid cation and thus increases the basic strength. However, in electron withdrawing groups, the group withdraws electron, destabilizes the conjugate acid and thus decreases the basic strength. So, this electron donating group, this is electron donating group, okay, like OH. So O along, we get minus, lone pair of electrons. No, oxygen has lone pair of electrons. So this lone pair of electrons, it bumps oxygen here, like this. So this oxygen goes, nitrogen pen charge in this lone pair of electrons can attack an electrophile easily. Okay. However, this NO2 group it's like this. This because N and O oxygen is more electronegative, so electron shifts towards oxygen. Because of this shifting electron, nitrogen becomes positive. Okay, because nitrogen becomes positive and you have carbon double bond. Electron rich, the electron shifts towards this side. So it's like this. So difference ahile electron donating group ahijangina because electron donating group pumps electrons to the ring. Lone pair of electrons becomes more available for donation. Lone pair of electrons pen donate jangina you get the basicity increases. However, electron donating group in electron pen withdraw more to their side. So a withdraw jangina this lone pair of electrons is not free. So a free logmanina it undergoes resonance with the ring. A resonance pain changina because it becomes less electronegative and nitrogen gains a positive charge. Because of that, the basicity decreases. Number 3 now this ortho effect. Then we have NO2 NH2, NO2, NH2. At para position, at meta position. The CH3 is at meta position, CH3 is at para position. Explanation ano. The effect of electron donating group and electron withdrawing group is more marked at para position than at meta position. Thus, para-toluene is more basic than meta-toluene, whereas para-nitroaniline is less basic than nitroaniline. Ortho-substituted anilines are usually weaker bases than aniline regardless of the nature of the substituent. This is called ortho effect. Thus, the basicity of ortho, meta and para-toluenes relative to aniline follows the sequence. So this substituents there, para position or meta position. This is para position or meta position omchangina a effect there ki increase mo. Male para position pen highly basic. So meta position sangin, then comes aniline, then comes toluene. So substituents there, yeah, ortho position, this one, adjacent position omchangina, this is called ortho effect. Ortho effect omchangina aniline then weak base, a basicity pen chow mo weak base maybe due to steric effect. Okay, so this becomes very weak. So ortho position occupied sangina, this becomes weak acid. So it becomes weaker base than aniline. The distinction between primary, secondary and tertiary amines. Amines pen primary ham, secondary ham or tertiary ham pen bangsi thailing ahile. This reaction ahile Hinsberg reaction akithaiting mo. So aniline pen amasana, they are soluble in dilute HCl due to the basic nature. So the three class of amines can be distinguished by reaction with benzene sulfonyl chloride or Hinsberg reaction in the presence of sodium hydroxide or potassium hydroxide. A primary amine reacts to give a clear solution which on acidification is an insoluble material. So you have primary amine, masanaina primary amine to benzene sulfonyl chloride na no danwa mo. If you react you get the alkyl benzene sulfonamide. So happen further reaction with sodium hydroxide, you get sulfonamide, salt of sodium. Secondary amine in a same type of reaction, same reagent same condition react you get NN dialkyl benzene sulfonamide. So this benzene sulfonamide pen further reaction sodium hydroxide to reaction pen pylomo, no reaction takes place. So tertiary amine a reagent no reaction. So you get salt of benzene sulfonic acid, which is insoluble but dissolves in acid. So first primary in a sodium hydroxide to react more. The secondary sodium hydroxide to react no. Third tertiary amine it does not react with the reagent but dissolves in acid. So uses of amines. Aromatic amines such as anilines they manufacture dye or drugs they manufacture na dia bol na dia kizang mo. Number 2, amines they rubber industry ayole phenyl isocyanide they bol na din kizanga khenkhat they polyurethane they bol na kizang. Number 3, aromatic amines the diazonium salts they are synthesized or bol na din kizanga. Diazonium salts are they're very important compounds here. Diazonium salt na tampi aromatic compounds they molania atamzo diazonium salt. Number 4, 5, low molecular mass of aliphatic amines find use as reagents in organic synthesis and as solvents in laboratory and industry. Aliphatic amines can organic synthesis reagent in solvent laboratory industry kizang. Number 6, quaternary ammonium salts they hile detergents atom zoa kizang. So organic compounds containing nitrogen class 12 is il take tingo here. Thank you.